The North American Cargo Securement Standard is a Canada-US cooperative project jointly administered by the Canadian Council of Motor Transport Administrators and the Commercial Vehicle Safety Alliance. Security of loads on vehicles is a matter of public safety and is therefore subject to government regulation. Regulations on loads on vehicles are set and enforced by the provinces and territories in Canada and the states in the U.S. In 2011, CVSA inspectors conducted about 2 million vehicle inspections. In the cargo securement sphere, the most common violations found during inspections were failure to prevent shifting cargo and leaking, spilling, blowing, falling cargo. 4 of the top 5 violations were damaged securement systems, loose or unfastened tie-downs, improper securement of heavy equipment, and failing to meet minimum tie-down requirements. Why must cargo be properly secured? The same forces you feel acting on your body while driving also act on the cargo you are carrying. Those forces are inertia, the feeling of being pulled forward out of the seat when you apply the brakes. It also applies to acceleration. Unsecured cargo will fall forward during braking and backwards during acceleration. Centrifugal force. This is what pushes you to the side of your seat when you go around a curve. Unsecured cargo can fall sideways. The higher the speed in the curve, the greater the effect. Gravity. When driving on a flat surface, gravity pushes directly downward on cargo. However, when going up or down a grade, gravity will push unsecured cargo the direction of the grade. The NACSS requires that cargo must be contained, immobilized, or secured, may not leak, spill, or blow, may not fall from or otherwise become dislodged from the vehicle, shift upon or within the vehicle to an extent that the vehicle's stability or maneuverability is adversely affected. Cargo must be secured to withstand forces of deceleration in a forward or rearward direction. This means the cargo securement system must withstand 0.8 g or 80% of the secured cargo's weight in the forward direction, 0.5 g or 50% of the cargo's weight in the rearward direction. This applies when accelerating, braking, shifting, and climbing hills. The cargo must also be secured to withstand lateral forces. It must withstand 0.5 g or 50% of the cargo's weight in either side direction. This applies when turning, braking while turning, and changing lanes. The cargo securement system must also withstand 20% of the cargo's weight when lifted upward from bumps or going over the top of a hill. Securing the cargo with tie-downs will usually meet this criteria. If the cargo is fully contained in a strong enough structure, it may also meet the requirements. Be aware that different means of securement will have different requirements. For example, chains have different requirements than rope. Some types of cargo have special securement requirements: logs, dressed lumber, metal coils, paper rolls, concrete pipe, intermodal containers, automobiles, light trucks and vans, heavy vehicles, equipment and machinery, flattened or crushed vehicles, roll-on, roll-off containers, and large boulders. Avoid a rollover. Commercial vehicles have a higher center of gravity than most vehicles. As loads are added, the center of gravity moves even higher. This gives commercial vehicles a much higher chance of a rollover. When driving through a curve, centrifugal force not only pushes the vehicle towards the outside edge of the road, but also pushes on the center of gravity, causing the vehicle to potentially tip or roll. Any corner taken at too high of speed will cause a rollover, but unsecured or unbalanced cargo amplifies the chance it will happen. Cargo should be secured as close to the center of the trailer as possible with heavy items lower. If carrying a large or top-heavy load, take extra precautions and go slower through curves. Driver and carrier responsibilities. Besides securing the cargo, various parts of the vehicle structure itself must also be secured. These include tailgate, doors, spare tires, cargo securement equipment, any other equipment. Any point on the vehicle used to secure cargo must be in proper working order when used to secure cargo with no obvious damage, distress, weakened parts, or weakened sections. The cargo itself must not obscure the driver's view ahead, left or right, interfere with movement of driver's arms and legs, prevent free and ready access to emergency supplies and equipment, prevent free and ready access of any person from the commercial vehicle's cab or driver's compartment. Penalties. Penalties for unsecured cargo, depending on the jurisdiction, can be fines to driver or carrier and/or the vehicle being placed out of service. Driver inspection. Pre-trip. Before beginning a trip, cargo and cargo securement equipment must be checked to ensure compliance with regulations. 80 kilometers. The cargo and cargo securement must be inspected again no more than 80 kilometers from the point which the cargo was loaded. Any needed adjustments to cargo securement can be made. 240 kilometers. Inspect cargo and cargo securement every 240 kilometers or 3 hours, whichever is first, or change in duty status. Packaging. If a package collapses or crumples in transit, cargo may shift or fall as the tie-downs have loosened. Though shippers usually are responsible for packaging, you must still inspect it to ensure there are no problems. If a problem is encountered, it is your responsibility to notify your carrier. Examples you may encounter include loose or improper banding on a package, improper wrapping, broken pallets. Loading and placement. Loads should be centered with weight low and evenly distributed. For example, no more than 60% of cargo weight on 50% of the deck. Cargo securement. A cargo securement system includes the structure of the vehicle, any securement devices, and blocking and bracing equipment. To be in compliance with the NACSS, the cargo securement must satisfy one of the following. Restrained. Cargo is not contained but is prevented from tipping or shifting. Contained. Cargo is contained if it fills a sighted vehicle and every article is in contact with or sufficiently close to a wall or other cargo so that it cannot shift or tip. Immobilized. Cargo is prevented from any form of movement. These 3 securement methods must each meet 6 requirements. The system must be appropriate for the cargo's size, shape, and weight. System is in good working order. No obvious damage or distress. No weakened parts or sections. Must be used within capabilities. Maintained by driver and carrier. Tie-downs are the most common way of securing cargo. Tie-downs attach to one or more anchor points on the vehicle to restrain the load. They can be utilized in 2 ways. Direct resistance. Attached to the cargo, the tie-downs directly restrain movement. Indirect resistance. Tie-downs are passed over or through to provide downward force. The force of friction restrains movement. A tie-down must meet the following requirements to work effectively. A tie-down, except for steel strapping, must be designed, constructed, and maintained so that the driver of the vehicle can tighten it. Each tie-down must be attached and secured in a manner that prevents it from becoming loose, unfastening, opening, or releasing while the vehicle is in transit. All components of a tie-down must be in proper working order with no knots and no obvious damage, distress, weakened parts, or weakened sections. All tie-downs and other components of a cargo securement system must be located inboard of the rub rails when a platform body is equipped with such a device. This requirement does not apply when the width of the load extends to or beyond the rub rails. Edge protection must be used where a tie-down would be subject to abrasion or cutting at the point where it touches an article of cargo. The edge protection must also resist abrasion, cutting, and crushing. A tie-down is deemed unacceptable and should not be used if there is visible damage such as cracks, breaks, pits, or large dents. Any damaged anchor points should not be used. Blocking and bracing. Timber or material used as dunnage, chocks, cradles, or for blocking or bracing must be strong enough to withstand being split or crushed by the cargo or tie-downs. Blocking wood should be hardwood, properly seasoned, free from rot, decay, knots, knot holes, and splits. Grain should run lengthwise. Shifting and tipping. To prevent shifting or tipping, cargo is immobilized or secured on or within a vehicle by tie-downs, along with blocking, bracing, friction mats, other cargo, void filler, combination of the above. Rolling. To prevent articles from rolling, lift the cargo off the deck and/or place chocks, wedges, a cradle, or other equivalent means that prevent rolling. These must be secured to the deck. The method used to prevent rolling cannot become unfastened or loose while the vehicle is in transit. How to tie downs. To determine how many tie downs are needed for a specific load and how the load should be placed, you need to know the following: length and weight of the load, if the cargo needs to be prevented from forward movement, strength of tie downs. Front end structures. A front end structure, also known as a header board, can be used to prevent a cargo from moving forward. Refer to the chart shown for front end structure requirements. Using tie-downs without blocking changes the normal tie-down requirements. Refer to the chart shown for tie-down requirements when no blocking is used. Note, if the cargo is fastened by other methods, the tie-down requirements do not apply. Examples include steel or concrete beams, girders, and trusses. Positioning tie-downs. Tie-downs should be positioned as close as possible to the spacer, as symmetrically as possible over the length of the article, to preserve the integrity of the article. Angles. If tie-downs are attached directly to cargo, the angle where the tie-down attaches to the vehicle should be shallow and not deep. If tie-downs pass over the cargo, the angle should be much steeper. The steeper the angle, the less shifting. For best results using indirect tie-downs, tension to as high as initial tension as possible. Recheck to ensure highest tension periodically. WLL and AWLL. WLL stands for Working Load Limit. It is the maximum load that may be applied to a component of a cargo securement system during normal service. The WLL is usually assigned by the component manufacturer. WLL for tie-downs. The WLL for a tie-down is the lowest limit of any of its parts or the limit of the anchor points it is attached to, whichever is less. For a synthetic webbing tie-down, the WLL is the limit of the tie-down assembly or the anchor point it is attached to, whichever is less. Note, the minimum WLL requirement for the securement system is 50%. More tie-down capacity should be used if needed to properly secure an article against movement. WLL for blocking. The WLL of all components used to block cargo from forward movement must be 50% or more of the weight of the article being blocked. Component marking. Some manufacturers mark the securing devices with a numeric WLL value. The limits of these devices is equal to this marked number. Some manufacturers may mark components using a code or symbol. For example, a piece of grade 7 chain may be marked with a 70 or 700 in accordance with the standard of the National Association of Chain Manufacturers. AWLL stands for Aggregate Working Weight Limit. It is the sum of the working load limit of each device used to secure an article. A WLL applies to a single component of a securement system, whereas an AWLL applies to all components of a securement system together. The requirement for any securement system is that the AWLL must be at least 50% of the weight of the cargo being secured. The same rule applies to components used for blocking cargo. Calculating AWLL. For tie-downs attached directly to cargo, in this case, 50% of the WLL for each needed component is added to the AWLL. For tie-downs that pass over or through cargo, add the full value of the WLL for each needed component to the AWLL. Cargo vans. The same performance criteria outlined by the NACSS applies to securing cargo inside a van. However, when securing cargo in a van, the vehicle structure is the main method used. The back doors act as part of the securement system when closed. Blocking and bracing equipment as well as dunnage and fillers are used to prevent shifting. Coverings. Coverings must be adequately secured so that it does not leak, spill, or blow off the vehicle. Inspect load covering when inspecting the cargo securement system.